All right. So, what's it called? What kind of reasoning is it when you kind of predict the future based on past examples?
Assumptions.
Predictions.
It's called inductive reasoning.
Knew it.
Kind of like educated guess. So on 1 through 3, we're supposed to predict the next couple numbers in the series. List them out. So what is the pattern on number 1?
It's happening every time.
Yeah, it's dividing by 2. So
Me too.
4 divided by, yeah, but we need 2 numbers. So, oh boy.
2 and 0.
2 and 1.
2 and 1.
And 5.
Because what's 2 divided by 2?
1.
Trey used to say facts like every other minute.
Facts. Facts, bruh.
Finally broke his habit.
I tried to ask Miss Arguello what's facts in Spanish, but Gianna said it doesn't exist.
Nah, it seems unlikely.
See, that's what I thought.
I think.
Well, maybe a synonym.
If I figure it out, I'll start saying it.
Okay, number 3. There's actually 2 patterns on number 3.
1, 4.
Oh, I get it.
It's like adding
9.
like 3, then adding 5, then adding 7, then adding 9. So it's just like adding 2.
Adding increasing odds. There's another pattern. It's also perfect squares. Like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the next one is 6 squared, which is,
46.
and 7 squared.
49.
14.
Oh wait, I think I need to do 4. I remember the other class. No, that was something else.
You can go ahead and do it.
That was algebra 2, not this one.
Yeah, no one.
Okay, make a conjecture describing each. So this is supposed to still be inductive reasoning, but you guys probably just know this. What's the product of 2 negative numbers?
Positive.
Positive.
Yeah. So smart.
Jaden
Yeah.
with the swish.
Yeah.
Yeah.
Yeah. I can't figure out to do. I don't know what to say. I just say
Yeah, there was number 2. We did do one of those on the homework. It was the tricky one off the homework, though. It wasn't the bonus, but it was another one. Anyway, number 7. Give a counter example. Actually, I will help you guys with 6 on this one. I changed it. Okay, so you guys remember what counter example means? Like one example to prove the statement is false. One example to prove the statement is false. So let's start with 7 because it's actually easier though. The sum of any 2 numbers is greater than either number. You guys remember what sum means? Yeah.
Adding.
So is it true that when you add 2 numbers together, the answer is bigger than
Yeah.
these 2
Yes.
numbers?
Not always. Yeah.
Well, they're saying there's a counterexample, so that's not true.
So it'd be like
If you add a negative, then it's.
Okay, you said if you had a negative. So like, if I did like -2 plus 3, that would equal 1. Is 1 bigger than both of those?
no.
No. So this is a counterexample, yeah. Paxton got it. Paxton for the 3.
Good job.
Okay, number 6. Nobody in the other class got this one, so.
I would.
Alright. He's calling his shot. He's pointing to the stands. Every ratio of integers is rational. What's rational mean? What's ratio of integers mean? Okay, ratio is like a fraction, right? Like 3 to 2 or something like that. So we need an example where that doesn't work.
Pi over 6.
Huh?
Pi over 2.
Pi is not an integer. A rational is just like a, anything that can be written like that, a fraction. Huh?
0.
Like 0 over 2? No, that still equals 0. That's still an integer. Or that's still a rational, I mean. But-
It's just 1.
The problem, the one that doesn't work is like over 0, because dividing by 0 is not gonna work.
It's gonna say error.
It's gonna say error because it doesn't exist. Number 9. Okay, state whether each sentence is a true statement, T, a false statement, F, or not a statement. So what makes a statement a statement?
It can be true.
If it can be true or false. Sometimes I think the line's a little fuzzy. Like if I said it's cold outside, it's kind of subjective. Is it true or false? Well, maybe, I don't know. All right. Anyway, number 9. Every triangle is a polygon. True. That's true.
True.
Polygon just means like straight edges. You guys remember that? Chapter 1. Number 11. Is it cold outside? Question mark. Not a statement.
I mean, it's chilly outside.
Anyways, number 13. All right, the symbols. Maybe I'll make up an example here. Do you guys remember what that symbol meant?
Congruent.
No.
Equilateral.
Compliment.
No.
Compliment.
So we're talking about like, okay, maybe I should start with this one. You guys remember that symbol?
Is then.
This means always, like, you're gonna have a statement like, P means, we won the game last night. Okay, so that means not P, so
Oh,
We-
it's a tilde.
we did, yeah, it's a lot, these are logic things. So this means we did not win the game last night. Okay, what does this mean?
We won the game.
Oh, we
We won.
always win the game.
We always won the game last night, I guess. I don't know. That doesn't make sense, but that one,
We never won the game last night.
sometimes.
Yeah, sometimes.
Okay, now the tricky ones were this, when you combine them. Not always, or you could say not all sometimes. That sounded confusing.
You say not all.
You could say not all on some sentences, but not all is also the same thing as saying some don't. Okay, this is also like some don't. Like for example, if I said not all people like Dr. Pepper, you're basically saying some people don't like Dr. Pepper. Okay, so not all or some don't. Okay, how about not some? What does that mean? Okay, if it's not some, it's like none. It's like not any, basically, so this is like none. Okay, so on 13, the statement is 3 points are collinear. That's the P, that's our statement. So what's the negation of that?
3 points are not collinear.
Yeah, 3 points are not collinear. Or you could say non-collinear. That's just the A.
Wait,
You could say 3 points are not collinear, or remember that just is another word for non-collinear. Doesn't matter. You don't have to say it exactly the same. Okay, and then we have this symbol. So what's that going to mean? All 3 points are, that's kind of a weird sentence, but I don't know if there's a better way to say it. All 3 points is the backwards E. So what are we gonna put for that one?
No.
Not all.
No. What did this thing mean?
Some.
I'm gonna put, I think it sounds a little better. Let's put sometimes. 3 points are collinear. Alright. Is there another one? D. One more. Okay, this one says squiggly all P. You could say, well, if you said not all 3 points are collinear, does that sound right? Kind of. I guess I would accept it. Not all 3 points, or you could say
No 3 points.
some 3 points are not collinear or non-collinear. Sometimes 3 points are non-collinear.
Would you
Kind
ever
of hard
say,
to grade these because there's different ways you could say it.
could you say no 3 points have, or no 3 points are collinear?
That'd be wrong. Not all doesn't mean none. It just means
Oh, some.
not all. Some aren't. Sometimes 3 points are non-collinear. That's what I'm going to say. The book probably said something a little bit different. Which that's a true statement, right? Sometimes they're not. Where was that? On 14 it says negate each statement. What do they mean by negate each statement?
Make it negative.
Yeah, you put a not in there, but make sure
If
it's,
you put 2 nots, is it a positive?
yeah. If the original statement was, I am not going to the store, then the negation of that is, I am going to the store. It's like saying the opposite of whatever they're saying. Okay, number 15. State whether each statement is a disjunction D or conjunction C and whether it's true or false. So do you guys remember what a disjunction or conjunction was?
Disjunction is or,
Yeah.
conjunction is and.
Yeah, Roman with the memory. Roman dunks it.
So disjunction is or.
Disjunctions or. So 15 says birds fly or fish swim. So that is or, so it's disjunction. And remember with the and, they both have to be true for it to be true. And the or, one of them has to be true, at least, for it to be true. So is that a true or false statement? Birds fly or fish swim? That's true. Both of them are true, so it's double true.
Well, not all birds can fly.
That's true. But can all fish swim though? Some weird fish that doesn't swim. Can you imagine it?
Yeah.
17. Every pyramid is a cone, and every prism is a cylinder. Conjunction, yeah. This was, the hard definition thing. All those pyramids fit in the cone category because they all come up to a point. And all the prisms fit in the cylinder category because they have two identical bases. So yeah, it is true. They're both true. Sounds dramatic, whatever they were watching.
Do you like hearing the same video every day from that class?
Well, it's always different, I think. It's always different. Always this.
Well, like throughout the whole day, you know what I mean?
Because there's different classes of like one class. So if you're watching the video in one class, he's gonna watch it in the other class that's the same.
If they are the same, I hadn't noticed. All right, number 19. Write the statement in if-then form. It also says write an equivalent disjunction. We never did that, so we're not going to do it now. But we are going to do the if-then thing. The pen writes because it has ink.
They can write that.
No. So the pen, the because part tells you the condition. So the pen being able to write is conditional on whether it has ink or not, right? So if the pen has ink, so it's kind of backwards from the original. Then it writes. No, we're not saying true false on this one. No. Okay. 21, right? The converse, the inverse, the contrapositive, whether it's true or false. Okay, what was the converse? We did a lot of these. You guys remember converse?
Is it like
You switched the if and the then. What was inverse? Stop doing the evens, pay attention. What's the inverse?
It's like the opposite.
Yeah, you negate each part of the if then statement. And what's the contrapositive?
it's like you switch and
Switch the order and you make it
make
make it negate both, yeah. So, and then we're going to say all three of them are true or false. So in 21 it says if two angles are adjacent, then they have a common side. So what's the common, or what's the converse of that?
Two angles have a common side. Then they're adjacent angles.
Yeah. I'm just going to say then they're adjacent. Okay, and then the inverse, so we're going to keep the original order, but instead of saying if two angles are adjacent, we're going to say if two angles are not adjacent. Then they don't have a common side. Forgot my name.
boom.
Okay, so the contrapositive, the last one, is we're going to switch the order and the negated. So it's kind of like the negated one, but in opposite order. So if two angles don't have a common side, then they are not adjacent. Alright, we are also, this one's kind of tricky with the true false, but we're also supposed to say if all these are true or false. If two angles have a common side, are they adjacent? You guys remember the definition of adjacent? Well, kind of. They have to have a common side and a common vertex. So technically, like, see if I can draw it right. Kind of missed. Like these two angles have a common side, but not a common vertex, so they're not adjacent. anyways, so they put false for that one.
Dang.
I'm talking about this first one. If two angles have a common side, then they're adjacent, and not necessarily. On this one, if two angles are not adjacent, and they don't have a common side, two angles are not adjacent.
I'd say true. It's false. It's false.
Well, okay, it's the same thing I just talked about. They could have, what's my place? If two angles are not adjacent, then they don't have a common side. Okay, so that picture I just drew, I erased it. These are not adjacent, but they do have a common side, so it's false again. Same idea. But the last one, if two angles don't have a common side, then they can't be adjacent. That's actually true. You have to have a common side and a common vertex. $23. Write the converse, which we already did on that. And then it says write the related biconditional. You guys remember what a biconditional was? It's when you connect both parts of the statement with an if and only if thing. It means it works both directions. The original works both ways. So on 23, what would the converse be?
If a figure has four sides, it is a triangle.
Oh, did they ask for true false on these?
What, you read that?
Yeah, they did. Well, we'll do that later. Okay, so to write the biconditional, we're going to take off the if and then from the original statement and connect it with if and only if.
So, main thing here is a triangle if and only if it has four sides.
Yeah. This kind of shows you where the cursive S came from. I see it. All right, anyways, oh yeah, we're supposed to say true or false. So on this one, we're supposed to say the original. If a figurehead is triangle, then it has four sides. True or false? False. And then the converse, if a figure has four sides, it's a triangle. False. Okay, if these are not both true, the biconditional won't be true because they has to work both ways for that to be true. False, false, false. Yeah, let's go to 25. Or 28, I mean. All right. This one says, state a valid conclusion for each set of premises, then classify each type of deductive argument. Do you guys remember the three kinds of deductive reasoning? Modus ponens. Transitivity, right. Modus ponens, modus tollens, transitivity.
I love this one.
Transitivity, we've used that one a lot. Later on we called it the transitive property when we got into geometry stuff. But it was, if A implies B and B implies C, that means A implies C. So that's transitivity. Modus ponens was like the basic one, like if I say, if I get paid, then I'm going to go to the store. and then I say, today I got paid. So what's your conclusion?
I go to the
And
store.
I'm going to the store. So that's modus ponens. It's kind of restating the conditional statement. Okay, but modus tollens, you guys remember that one? Was where you did a contrapositive. You like flipped it around. So if I said, I did not go to the store, so what can you conclude?
I did not get paid.
I did not get paid. So that's modus tollens, or it's backwards. I kind of think of it in alphabetical order. Ponens before tollens. Ponens is basic, tollens is contrapositive, where it's flipped. Contrapositive means not the second one, implies not the first one. Okay, 25. So we need a conclusion, and then we need what kind of logic is it? If grandma makes cookies, then the children will eat them. If the children eat cookies, then they will not eat their supper.
The children.
No, okay, we need a conclusion.
The children ate the cookies. Wait.
Okay, let's go through it again. We need to conclude something from what they're saying here. If grandma makes cookies, then the children will eat them. If the children eat the cookies, they will not eat their supper.
So they will not eat
Will not eat dinner if they eat the cookies.
No, they said that one already.
If grandma makes the cookies, the children will not eat supper.
Yeah. Grandma makes cookies, children will eat them. If the children eat them, then they won't eat supper. Therefore, if grandma makes cookies, you guys following this?
Yeah.
If grandma makes cookies, what's going to happen?
The children won't eat their supper.
Yeah.
And that's transitivity.
Yeah. Won't eat supper. Transitivity. Yucky. Yuck. Okay, one more. If a person understands reasoning, then he is likely to succeed in geometry. You understand reasoning, therefore, what?
Therefore, I'm good at geometry, or I succeed at geometry.
You are likely to succeed and what kind of reasoning?
Modus pol, or modus.
Yeah, we're kind of restating the original conditional statement, right? So modus